Pluto's way will undoubtedly cause issues. From the very beginning, Pluto's circle crosses that of another planet. Pluto, the strange and small planet found in the farthest corners of our sunlight-based framework, has turned into a hotly debated issue in cosmology. Ongoing updates recommend an expected impact with Neptune, raising cautions among researchers and space lovers. Prestigious figures, for example, Neil deGrasse Tyson and Michio Kaku, have communicated concerns with respect to the potential consequences of this heavenly experience. Yet, how did Pluto end up on a crash course with Neptune? And what could this cosmic conflict mean for Earth? Join us as we investigate the subtleties of how a monstrous event with Neptune could have happened. Furthermore, why researchers are grieved by this infinite oddity. Pluto, once celebrated as an undeniable planet, went through a sensational renaming as a dwarf planet, to a great extent in light of its sporadic circle. Notwithstanding this minimization, Pluto proceeds to entrance and start interest inside the galactic community. Late alerts from conspicuous researchers, for example, Neil deGrasse Tyson and Michio Kaku, have proposed that Pluto's way could cross that of Neptune, suggesting a possible risk of crash with serious ramifications for our planet. Pluto's excursion around the Sun is unprecedented because of its extraordinary qualities. Its circle is incredibly lengthy, taking a huge 248 years to finish. Since its discovery in 1930, Pluto has not yet completed a full revolution around the Sun. What makes Pluto much more interesting is the outrageous curved state of its circle, a glaring difference to the almost roundabout circles of the significant planets. Moreover, Pluto's circle is shifted at a point of 17 degrees relative to the ecliptic plane, bringing about a more extreme grade compared to the ways of different planets. This blend of tendency and its extended circle adds intricacy to its movement. A striking part of Pluto's circle is its rehashed convergence with Neptune's circle. Like clockwork, Pluto's way carries it nearer to the Sun than Neptune, which challenges what we would anticipate from their relative situations in the planetary group. Further investigation uncovers that Pluto's circle is nowhere near a perfect circle. Rather, it follows a curved or oval way, implying that its distance from the Sun changes altogether throughout its circle. At its nearest point, Pluto goes inside around 30 astronomical units from the Sun. However, at its farthest, it extends to more than 49 astronomical units, almost double the distance of Neptune from the Sun. Besides, Pluto's circle is slanted at a point to the circles of the other planets, adding one more layer of intricacy to its relationship with Neptune. This tendency plays an imperative job in how Pluto and Neptune associate. When their circles run into each other, their gravitational forces pull at one another, step by step changing their directions. This dynamic among Pluto and Neptune highlights the interconnected nature of the planetary system, with every planet applying gravitational forces that impact the movements of others. Over the years, mechanical progressions in observational instruments have permitted stargazers to track Pluto's development with more accuracy. This has prompted a better understanding of its circle and its expected effect on the general stability of the outer nearby planetary group. Although the probability of a direct crash between Pluto and Neptune remains low, the chance is still under a microscope. Continuous monitoring continues, as the potential results of such an impact could be dramatic. In spite of Pluto's small size and its far-off area, it continues to be a subject of interest for researchers and space fans alike. A key question that arises is, why hasn't Pluto crashed into Neptune already? The response lies in the gravitational influence of different planets. From the second Pluto was discovered, stargazers have been attempting to comprehend its way. Not at all like most planets, which keep a predictable circle along the ecliptic plane, Pluto's circle stands out with its lofty point and circular shape. The mystery developed when it became apparent that Pluto's circle crosses Neptune's. Notwithstanding this apparent risk, Pluto's circle remains surprisingly stable, illustrating the refined mechanics that govern space. Studying the interactions between Pluto, Neptune, and the Sun presents a significant challenge for astronomers. Predicting their movements involves a profound understanding of how they impact each other's directions. To explore this challenge, Researchers depend on conditions such as azimuthal libration, scope libration, and VSOP and Steve's and Kaplan's confinement to address this astronomical puzzle. Azimuthal libration, for instance, is fundamental in maintaining the stability of planetary circles. When Pluto crosses Neptune's way, it stays at least 90 degrees away, preventing an immediate impact. Scope libration ensures that when Pluto approaches Neptune or other large planets, it is situated above their way, reducing the probability of an accident. The VSOP swaying, named after researchers von Zeipel, Steves, and Kaplan, explains why Pluto's circle appears strange but remains stable over time. Even though space seems tumultuous, there are fundamental patterns that help maintain order. These patterns are responsible for keeping Pluto from crashing into Neptune or significantly altering its circle. The concept of orbital chaos, which describes how a celestial body's direction is extremely sensitive to its initial position, is clearly demonstrated by Pluto's circle. Even small variations in Pluto's position or speed can have significant impacts over long periods. Researchers use advanced virtual simulations to model Pluto's interactions with other bodies in space, like Neptune, and to explore the consequences of even minor changes in its direction. In the late 1980s, these simulations revealed something captivating. Despite the apparent stability of Pluto's circle, it can still act erratically. A small change in Pluto's starting point or speed could lead to massive changes in its circle over time. Anyway, even with these vulnerabilities, Pluto's circle remains stable for billions of years, suggesting that, despite its unpredictable appearance, it follows a hidden order. The capriciousness of planetary circles, such as Pluto's, makes it difficult to predict long-term changes with certainty. These models require highly accurate initial conditions, as even small errors in data can produce vastly different outcomes, making precise predictions incredibly challenging. Understanding Pluto's circle is fundamental, especially when considering the potential for a future crash with Neptune. This information adds to a broader understanding of how our solar system works. Pluto's circle serves as an example of how seemingly chaotic paths can eventually reach an equilibrium, directed by the forces of gravity and motion. We truly need to continue observing and studying these celestial mechanics to gain a better understanding of our position in the universe. Pluto's circle offers an ideal illustration of the unpredictable nature of space. Despite the intricate mechanics of Pluto's orbit and the unlikely prospect of a collision with Neptune, the ongoing study of such cosmic phenomena remains essential for understanding the dynamics of our solar system. As technology advances, astronomers are able to refine their models and simulations, providing us with more detailed insights into the long-term behavior of planets like Pluto. The curiosity surrounding Pluto's orbit, its eccentricity, inclination, and the potential for rare encounters with Neptune reminds us of the vast and unpredictable nature of space. Moreover, studying Pluto also serves as a reminder of how the forces at play in our solar system are both delicate and powerful. The gravitational interactions between planets and other celestial bodies can result in dramatic changes over time. Yet many of these interactions also help maintain the delicate balance that ensures the stability of planetary orbits. Pluto's strange and fascinating journey around the Sun serves as a key piece of the cosmic puzzle, helping scientists better understand the forces that govern not only our immediate neighborhood in the solar system, but also the broader universe. This investigation into Pluto's orbit, its possible interactions with Neptune, and the very nature of celestial mechanics also raises profound questions about the future of our own planet. While the probability of a collision with Pluto is minimal, understanding these cosmic phenomena allows us to contemplate the larger forces at play in the universe, forces that shape the path of Earth and every other object in the cosmos. Whether it's Pluto's bizarre orbit or the stability of our own planet, the study of space ultimately helps us better understand our place in the vast and ever-changing universe. As research continues and new discoveries are made, we may find even more surprising facts about Pluto, Neptune, and other distant members of our solar system. But for now, the mystery of Pluto's orbit, along with its potential interactions with Neptune, continues to spark both wonder and concern among scientists, space enthusiasts, and anyone fascinated by the universe we call home. Pluto's circle is not normal for that of the different planets, with its oval shape prompting flighty experiences with Neptune. This unpredictable movement makes it hard to foresee the long-haul elements of the framework. Anyway, gravitational powers assume a significant part in keeping Pluto and Neptune from impacting. Gravity, a force that draws objects to each other, guarantees that in spite of their meeting circles, the two bodies stay separated most of the time. These interactions mirror the sensitive equilibrium of forces at work in space. The probability of a crash between Pluto and Neptune, while impossible, would be an amazing occasion with huge outcomes. Such an occasion would definitely modify how we might interpret the planetary group. However, space investigation has progressed significantly. Pluto's circle fills in as a sign of the numerous questions that still exist. Researchers continue to concentrate on Pluto's way to better understand how huge planets impact its movement. This information is critical for understanding the complex connections between divine bodies and how their developments can influence each other. In spite of the uncommon nature of Pluto's circle, some of the world's driving researchers, like Neil deGrasse Tyson, have conjectured that Pluto might, one day, at some point, slam into Neptune. Tyson, a conspicuous astrophysicist, sees Pluto's renaming as a dwarf planet as a vital step, recognizing the significance of continued investigation and study. He believes that Pluto's odd circle highlights the fact that there is still a lot to discover about space and the forces at work within it. As indicated by Tyson, the mysteries of space are what makes studying it so fascinating, and he urges others to engage with the intriguing intricacies of celestial mechanics. Tyson, alongside different specialists, is worried about the potential risks presented by Pluto's uncommon way. If a crash between Pluto and Neptune were to happen, it could have disastrous ramifications for our planetary group. The release of energy from such an event would be tremendous, and the flotsam and jetsam dispersed all through space could have expansive impacts, possibly even affecting different planets and moons. Neptune itself would be impacted, and its circle could be modified, further entangling the elements of the external nearby planet group. Renowned theoretical physicist Michio Kaku, who is known for his work in string theory, also provides significant insight into space investigation. Kaku believes that concentrating on peculiarities like Pluto's circle is fundamental for understanding the broader principles of celestial mechanics and theoretical physics. He suggests that the study of Pluto's interactions with Neptune can assist researchers in exploring future space missions more safely. Kaku, too, emphasizes the importance of understanding gravitational forces in the context of space exploration, as they can potentially shape the future of how we investigate distant worlds. Kaku's work in string theory, which attempts to explain the fundamental forces of the universe, aligns with his interest in Pluto's circle. An impact between Pluto and Neptune could offer valuable information that would contribute to our understanding of gravity and space-time regions, key to string theory. Despite the fact that such an event would have minimal direct influence on Earth, it could provide a unique opportunity to study the behavior of fundamental forces in extreme conditions. As researchers continue to explore the depths of space, the unpredictability of planetary interactions becomes clearer. The study of celestial dynamics, for example, the complex gravitational relationship between Pluto and Neptune, offers valuable insights into the fundamental laws of the universe. By continuing to monitor and study these phenomena, we draw closer to understanding the vast and complex nature of the universe. The gravitational dance between Pluto and Neptune highlights how even distant planets can impact each other. These celestial bodies apply gravitational forces that, over extensive stretches, can shape their orbits in subtle but significant ways. While an immediate impact remains far-fetched, the possibility can't be completely ruled out, leading to ongoing interest and observation from the galactic community. Researchers hope that understanding these forces might one day allow them to predict and possibly mitigate the risks presented by such cosmic events. One fascinating aspect of planetary movement is the way seemingly irregular or turbulent interactions can lead to stable, predictable patterns. This phenomenon is especially evident in the case of Pluto, whose orbit may appear erratic, but is actually governed by exact gravitational forces. These forces help prevent Pluto from colliding with Neptune, despite the apparent overlap in their paths. The delicate balance between the gravitational pull of other planets and Pluto's orbit keeps the dwarf planet on a steady yet complex course. Understanding this intricate relationship is essential for advancing our knowledge of the broader solar system. As researchers continue to study the unique qualities of Pluto's orbit, they also look toward other areas of space investigation. The study of systems like the TRAPPIST-1 system, which contains several Earth-sized planets, helps space scientists understand how gravitational forces between planets can lead to orbital resonances. Moreover, in some cases, they can increase the chances of a planet's orbit becoming unstable. However, the TRAPPIST-1 system is not currently experiencing any such effects. Researchers remain cautious, monitoring the movement of planets in these crowded conditions to better understand the risks and how they might develop over time. In the meantime, astronomers are also focused on understanding the behavior of rogue planets, which wander through space without being bound to a star.